So what I want you to do is with your partner, I want you to go through this question, answer the two questions at the end in red, using the information provided in the problem here. I want you to pause the video right now and do that task. When you think you have an answer, go ahead and hit play. All right, so hopefully now you have an answer to these two questions. But my question to you is, did you use algebra? What I want you to do right now, now that you've gotten this, I want you to try to use some algebra to figure out this question of what is the maximum number of people that may rent a boat without sinking it, all right? So remember, choose your variable, your unknown, okay? And then figure out an expression to go with that. And also you're going to want to use this 1,200 pounds, right? Because that's the maximum that each boat can carry as far as pounds go. So write an expression to figure out how many people you could put on there, including their gear, that would get you to 1,200 pounds. Pause the video now and complete that. So, a couple of things to highlight here. First of all, each boat can only carry 1,200 pounds. So that's obviously going to be our max. So the max is going to end up equaling 1,200. All right? Each person is, we're going to assume 150 pounds. So every time you put a person in, you're going to have 150 pounds for each person. You also have 200 pounds of gear, no matter what, plus, that's probably an important word there, plus 10 pounds for each person. Notice that you should have noticed the key word there, each. So what am I doing? Each person is, every time I put another person on, I'm adding 10 pounds. So that's repeated addition. We're going to multiply. Now what I don't know, X, is number of people. I don't know that. So what I need to do then is, I need to use that in my expression. So the number of people, okay, each of those is going to be 150. So every time I add a person, I'm going to be adding 150. So that's 150 times X. Plus 10 pounds for each person as well. And then we also have 200 pounds no matter what. So this is the gear. This is the weight per person, and this is the weight of the gear per person. So altogether, every person that comes in, you might have done this in your work if I combine like terms, every person that comes in is going to add 160 pounds. Notice 160 per person. That's going to get us to 1,200. Okay? Now, I can solve this equation. Remember, we're figuring out, first of all, we have to figure out, if we want to know what X, we have to know what 160 X's is. So remember, we're going reverse order of operations. We've got to subtract the 200 out of there. And I get 160 equals 1,000, 160x. Divide both sides by 160. And we get 1,000 divided by 160, 6.25 people. Well, obviously, you can't have 1/4 of a person. That would be gross. It's a little murder joke there. You can't cut paper on it, never mind. All right, so obviously our answer here, logically, is we can have a maximum of 6 people. If I go up to 7 people, I'm over the weight limit. Now, the issue is this. 6 is not our only answer. I could have 6, 5, 4, 3, 2, 1, or 0 people in the boat, technically. So how do I show that? How do I show every possible answer? Well, the answer to that question is that we cannot use an equation for this. We have to use an inequality. So the question is, what is an inequality? Pause the video right now, have a little discussion with your partner, see if you can remember what that is. So an inequality basically boils down to this. See if you remember. It's a comparison between two quantities. That might not ring a bell. However, by the way, you should be taking notes on this. This probably does. Less than or greater than. Okay? Less than or greater than. Those are inequalities. So when I say 3 is less than 7, you are comparing these two quantities. There's another one we want to add, which is this one. Notice there's a line underneath the less than symbol. This simply means less than or equal to. So if I write 7 is less than 7, that's not true. However, if I were to write 7 is less than or equal to 7, that would be true. It's an or question, so if it's not less than, but it is equal to, so that's okay. So an algebraic inequality then, just like an algebraic equation, is basically an inequality that contains a variable. So x is greater than or equal to 7. So how does this relate to our problem that we just did? Remember, we had multiple solutions. Notice, x is greater than or equal to 7. Think about how many solutions I have for x. Remember what a solution is? It's a number that if I plug it in for the variable, makes the whole thing true. So I could plug in 8 here. I could plug in 9, 10, 11, 12. I could go all the way up to infinity. I could plug in 7.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 because it's greater than or equal to 7, all right? So there are an infinite number of solutions because it's greater than or equal to 7, all right? So there are an infinite number of solutions here. Think about how that relates to our problem. There weren't an infinite number of solutions, but there were more than one. And we call all the solutions that we have here the solution set. All solutions that work for an algebraic inequality. Okay? So if we go back to our problem here, notice equals is not necessarily true. Okay? It could equal 1,200, right? Theoretically, if we could make 0.25 people get in the boat, okay, we could equal 1,200 and the boat would not sink. But technically, I need to be under 1,200. So think about it. I want you to, in a second, I'll pause the video, and I want you to think which inequality sign would go there to show that 1,200 is our maximum. So what you should have discussed is, hey, this has to be under 1,200. So that means I have to be less than 1,200. Now I'm going to put or equal to, because technically we could equal 1,200. If we could get 0.25 of a person in there, technically that would be true. And now notice what happens. The process for solving this, folks, is exactly the same as you solve an equation. Exactly the same. Nothing different. You still do opposite operations. But notice now, I'm saying that my solution set is everything and everything equal to 6.25. How do we show that? Because I can't write all those numbers. You might think you can write 1, 2, 3, 4, 5, 6, but you're forgetting some numbers there. You're forgetting 1.1, 1.2, 1.3. And if you write all those, you're forgetting the numbers in between 1 and 1.1. You gotta remember that in between any two numbers you give me, there are an infinite number of numbers. So we need a way to show all of this entire solution set. You've heard a picture is worth 1,000 words. Well, we actually have quite a few numbers here we have to show. So what we're going to do is we're going to draw a picture. And that picture we're going to draw it on a number line. So on our number line, obviously, 6 is a very important number, okay? So we'll go actually 6, 7, 5, okay? We'll put 3 numbers on there. And actually 6.25 is the number we want to go all the way up to. So what I'm going to do is I'm going to put a dot at 6.25. I'm going to fill it in. That's important for later. Okay, dot at 6.25. And notice it's everything under 6.25. So if I pick a number, let's see, 6 is less than that, 5 is less than that. So basically, everything under 6.25, I'm going to kind of shade in. Now I need to show that this goes on and on forever. So what I'll do is I'll draw an arrow at the end. And notice I've made a ray. Remember, a ray starts at one point and goes on and on forever. Everything the ray touches is a solution to this inequality right here. Okay? So that's how we show all these solutions. Now there is one wrinkle. Let's say that we change the problem just a bit. And let's say that if I get 1,200 pounds, the boat sinks. Notice what that does. Now I can no longer equal 1,200 pounds, right? So here's the issue. Now, 6.25 is not a solution. It can't equal 6.25. It can equal everything up to 6.25, but it can't actually equal it. So you might say, okay, what if we put a dot really, really close to it? Well, then I could take another dot and put it even closer. And then you could take another dot and put it even closer. We can go on and on like that until the end of infinity. Okay? So what we do is this. We're still going to put a dot at 6.25, but we're not going to fill it in. That's going to show that this is our breaking point. Anything bigger than this doesn't work. Anything smaller than this does work. Okay? And by the way, if we were going over 1,200 the arrow would go the other way. Okay? There's no breaking point, but this does not count in the solution set. All right? So one little thing you might want to write here, a little key. If you have an open dot, that means you had a less than or greater than sign. So remember, less than or greater than, it's not or equal to. If it were equal to it, it would be part of the solution set. If I have a closed dot, that means it's got the little line underneath. Remember, little line underneath, take a little bit of extra lead, fill that in. Okay? So what I want you to do right now is this. Okay? Underneath this video, you have these 5 problems. A lot easier. What I want you to do is I want you to practice solving these and graphing the solution set, showing all of the possible answers on the number line. When you are done with this, turn it in so that I can check it and show that you've mastered this material. That's it. Let me know if you have any questions.